My name is Julia, and I am a research engineer at Lakera. And maybe you know Gandalf. Does anyone here know Gandalf? I see a hand up. Exactly, that's a prompt injection game that we launched. I guess you can even say a few years ago. Time flies. And um, but besides this, we kind of do a few things around AI security. And that's mainly on the blue side, so building defenses so you can deploy chatbots without worrying that they get manipulated and bad things happen to them. But also we do kind of the red side of things to kind of keep the flywheel going. And we're a Zurich-based startup that got acquired half a year ago by Checkpoint, which is like a big cybersecurity player in the cybersecurity space. But uh, enough about me. Um, let's talk business. So I'm here to talk to you about work that we did based on Gandalf actually. But first, I've so far the few times that I've been here, I've seen that people here have mostly background in AI control, and I think there is some linguistic differences and differences in how problems are framed in comparison to what we do in the industry. And I feel like these two areas have kind of grown to have their own framing of the problem and their own vocabulary for things. And so we are building defenses, and that's what people in AI control would call monitors, for example. And first, I want to tell you how I see the difference between what's AI safety and what's AI security. And if we think about a bike is unsafe when, for example, the brakes don't work, and then you can hurt yourself when you're riding it, right? On the other hand, the bike is insecure if it's can be easily stolen, for example. So we can extend this intuition to AI systems. Mm. And if you think about this, if you so just one thing, I will be talking mostly about specific AI systems and applications built with LLMs or LLM agents, things like this, and not just like LLMs in general, if that makes sense. So this is not necessarily talking about capabilities of the core capabilities of LLMs, but capabilities of LLMs in a specific application. So here, if you think about this, the question is, can the user of the system be harmed versus can the system itself be harmed? And if we take a look at what this means specifically for AI, mm, that's here's a bit of a cloud of concepts that came to my mind when I was preparing these slides. And I don't think there is a clear formalized definition of the two. I believe these two are very strongly intertwined, but I just want to provide you a bit of an intuition of why there are even specific different words used for the two. Mm. And I don't want to go through all of these, if any of these phrases is unfamiliar to you, go ahead and Google it because although each of these is like a whole chapter. But what's important here is that each security vulnerability can potentially lead to a safety failure. So safety is kind of the potential of a model to misbehave in some way, and then through the lack of security, we allow potential attackers to use that. Mm, yeah, but maybe let's take a step back now. And so I've been in Lakera for almost 3 years now, and at the stage when we were starting, we were just launching our product. There, people didn't know much what prompt injections are, and people were not necessarily very convinced that you need to secure against them. So the landscape has changed a lot. That's not because that's not the case anymore. nowadays. But before like ChatGPT dropped, we had just traditional software with issues still, but like more or less solved with risk that we accept. But then people started building chatbots. So you started having these human in the loop chatbot applications, which have some capabilities, but are mostly meant to like interact with the humans. And that's like some AI assistants that you see here and there. There's like the talk to your data setups, talk to your documentation sort of a thing. And this already brought a bunch of problems. But these being mostly like either reputational, some data exfiltration things, um, some data leakage, but not like the world has not ended though. But in the last year or so, we kind of have seen the vast expanse of capabilities because not only we expanded the interfaces that the different modalities that the agents can consume, but we also hooked them up through like MCPs and tools. We hooked them up to systems, and now they can actually do things in the virtual world, and that changes the landscape a bit. Because now it's not mostly about interacting with the human. Now it's about doing things, and this led to a bunch of more issues. So this is a slide that is kind of like evergreen for me. I always show it in presentations, and every time I show it, I add a few things to it. So uh, there's more and more interesting things happening. And I think one worth noting was that recently there was a case of an entire company losing all of their data because they trusted their AI agent with the possibility to just delete all the data volumes and also the backups. So at some point, the agent just decided to do that, and that was pretty painful. Mm, yeah, so what sets apart these from the previous slides is that this is actually painful stuff. This is exfiltrating like full message histories through WhatsApp. This is like deleting all of your emails, losing all of your company data. This is kind of the blast radius is one step larger. And now we can get to the core of this talk, and that's the work that we recently published at ICLR in collaboration with the UK ASI. And the point of this work is to be able to evaluate different large language models as kind of the backbones powering agents. So we want to be able to say how, like, kind of, give practical advice for people building agents, what large language models they should use. And I want to walk you through an example. So here is an example agentic workflow that's like deep research, where first an LLM call produces a research plan, then subsequent LLM calls search the web and gather data, and then based on that, a report is created. And that's kind of the deliverable that goes to the user. So this is like kind of a relatively simple agent. And when you want to know how robust and how resilient this agent is to external attacks or like potential people who might want to abuse it, you input the attacks somewhere into the data that the agent consumes, and you execute the whole agentic workflow. And there's a few issues here. So number one, that's like really expensive. Like running agents is pretty pricey these days still. On top of that, as you're like evaluating your LLM under attack, you need to really sandbox this. So you're not gonna run this in your production environment, right? You need to sandbox this. You need to um, mock all the data sources. You cannot use your actual client data here for obvious reasons because bad things could happen. But what's the third thing that's an issue here, and that's even more important, is that This only gives you kind of an end-to-end evaluation of the safety and security of the system, mm, which is useful. But at the point when you want to improve it, you don't really have the fine-grained information. So what we propose in our work is the so-called threat snapshots. And that means that we focus on a specific step of the agentic workflow, identify various vulnerabilities there, and evaluate how susceptible large language models are to those specific vulnerabilities in these specific agent states. So a single threat snapshot has the full agent state that has all of the information about the agent, all the context that it has, memories, whatever you need, what tools it can execute. All of this is packaged there. So we treat agents as completely stateless. So you just have this, and that allows you to execute the next step. And additionally, we also have the full threat description. So the attacker objective, the attack vector, and basically how to evaluate the attack. And this allows us to single out components of the whole system in order to evaluate how vulnerable these specific components are. So in this example, we can just evaluate the specific create report step by injecting the search results that are already aggregated by the previous LLM step to produce the report. So here's a quick comparison that kind of allows us to basically execute these evaluations significantly cheaper. It's so much easier to run because you can just mock all the data. You don't need to actually execute tools, and you have specific you know exactly which step you need to work on to make your system more robust. However, this kind of doesn't give us the end-to-end risk assessment, but rather component by component that then you can kind of aggregate to have some estimate of the risk. And I mean, kind of the bitter truth here is that I think that if you're deploying really crucial systems, you need to do both. So if you have a background in software engineering, I would say that the end-to-end evaluations are like integration tests, while threat snapshots are unit tests for agent security. This end-to-end evaluation things, this is something that we worked on with NVIDIA, but I'm here to talk to you about this other work on threat snapshots. And yeah, so I mentioned already Gandalf, and that this is maybe the page that people know. But last summer we expanded Gandalf into a Gandalf agent breaker, and here we had mocked agents and mocked agentic environments where people were tasked with executing very specific attacks. And the trick here is that this is not produce harmful content. This is not how do I make meth or how do I make bioweapons. No, this is more how do I convince the agent to include a specific package I want in its code, or how do I make the agent just produce misinformation during the financial analysis of some financial reports of a company. So this is not directly related to harmful content, but rather to instruction following of the agent. And we constructed these to kind of cover a variety of attack vectors, difficulties, and objectives that potential attackers can have. And we ran this for 2 months, I think. I mean, it's still running, but at the time of writing this paper, it had been running for 2 months, and we gathered almost 200,000 attacks. We selected the creme of the creme de la creme of the attacks. So we selected the attacks that are the most high quality and the most generalizable as well. And that allowed us to run a very thorough evaluation of many different large language models. And I have a few results to share here with you. So because this benchmark is quite relatively cheap to run, we could run this on like 30 different large language models. And what was really surprising to me was that, well, of course, cloud models would be particularly secure because these are, well, kind of well-known. Anthropic is well-known to care about safety and security. But on top of that, the Grok models were actually doing great as well. So this is a pretty surprising result. But another thing here is that if you look at this plot, the striped bars are open weight models. And at first sight, this is quite discouraging because like our open weights models really like lagging behind in security. That's well, that's a bit discouraging. However, well, when I run an open weights model, I know I just run the model. If we're querying the OpenAI API, if we're querying the Anthropic API, you don't really know what's going on there. Or even more so, I'm 100% sure, and I know for a fact that they're running various different systems that are meant to also protect their LLMs from manipulation. So it's kind of expected that open weights models will be scoring worse in this benchmark. Another takeaway here is that if you're building an agent and you're like concerned about a very specific risk, you need to evaluate it for that specific risk. So here on the x-axis, you have various different task types. I don't want to get into the details of it, but the second column, for example, is how easy it is to pull out the system prompt and the system configuration from the model. And you can see that Grok 4 Fast, the orange cross is pretty resistant here. But the moment when um, in the third column, when you want when you want it to convince the model to follow the user instructions instead of the system prompt, it's relatively easy to do. So it's really, you really need to kind of evaluate for your specific use case because maybe you care about some things more than others. And something that I found really interesting from these results was that larger doesn't necessarily mean more secure. So I was coming into this thinking, okay, larger models, more capable, going to be more secure, right? That doesn't seem to be the case. So there is like from everything that we run here is no support for that. There is one thing though that helps, and that's that if you are running a large model, then enabling reasoning will probably make it more secure. So here you can see the same models run with and without reasoning, and from almost all of the models, they get they are either as secure or get significantly more secure when you enable the reasoning, except for the two very tiny models on this list, which are GPT-5 Nano and Gemini 2.5 Flashlight. So we can, of course, only speculate about the sizes, but these are the smallest in their class. And it seems that for them, if you enable the reasoning, they just get much more confused. I find this a pretty interesting result, and it would be cool to explore it further one day. And the last takeaway here is that the security and quality are correlated. So here on the x-axis, you can see the artificial analysis benchmark score. So that's like an aggregator of different benchmarks for LLMs. And you can see that there is quite a clear line that's going there down. So the more capable the models are, the less vulnerable they are. However, that's not like a rule, of course. but there is a general tendency. You can see quite a few outliers here. Yeah, so if we like take a look to the future here, well, models evolve, and thus the benchmark that we developed has to evolve. And in general, benchmarks like these, I believe they have to evolve. One, because of like, of course, data leakage, right? But also, doing security benchmarks is particularly, well, problematic because it's very hard to get the data. So we managed to crowdsource it, but ideally, I would want, instead of like 10 different agentic applications, I would want to have 1,000 of them and have very effective attacks there. But that's, um, let's say that that's kind of the holy grail of AI security, to be able to do this in a fully automated fashion on a black box model. Yeah, and all of this work that I showed you focuses on like specifically LLM vulnerabilities, but there is like much more around there. Like there is like things like static analysis of agentic workflows that you can do, so you can analyze the tools that the agent can call. You can analyze accesses and services that it can access to kind of get a picture of what could go wrong even before running anything. And of course, as I mentioned earlier, you do need like these end-to-end agent simulations as well to kind of have like the full picture of, well, the resilience of whatever you're building. Um, and that's everything from my side, and I'm happy to take questions.